Here we will see linspace function in NumPy. This function is similar to arrange function. However, it doesn't allow user to specify the step size in the syntax. Instead of step size, linspace function is used to create an array of evenly spaced numbers within a specified range. This range is defined by the start and end points of the sequence and the number of evenly spaced points to be generated between them. Here the system implicitly calculates the step size. It is primarily used in data analysis and visualization to generate a sequence of numbers for constructing a range of values for analysis, plotting graphs, etc. General syntax is numpy.linspace with parameters start, stop, num, endpoint, return step, dtype and axis, where start is a required parameter which is the starting point of the interval range. The sequence will begin at this value. Stop is also a required parameter which is the end point of the interval range. Depending on the value of the endpoint parameter, this value may or may not be included in the generated sequence. Num is an optional parameter which is the number of samples to generate. The default value is 50. It must be a non-negative integer. Endpoint is also an optional parameter which is a boolean value. If it is set to true, the stop parameter will be included as the last sample in the sequence. And if it is false, the sequence will not include the stop value. The default value is true. Return step is an optional parameter which is a boolean value. If it is set to true, the function returns a tuple, that is samples and steps, where step is the spacing between samples. The default value is false, which means only sequence will be returned. dtype is an optional parameter which specifies the data type of the output array. If not provided, the function will return the data type based on the input argument. And axis is also optional parameter which specifies the axis along which the sequence should be filled in the output array. The default value is 0. For example, if we define an array with np.linspace with parameters 0, 1, 5, it will create an array of evenly spaced 5 numbers ranging from 0 to 1. The difference between consecutive number is 0.25, which is a step size. As shown here, if we give the linspace with 0, 1, 5, it will generate 5 elements with evenly spaces. Here we will see creating a simple array with or without endpoint. By default, the endpoint value is true, that is the stop value is included. So if we run the command np.linspace with 0, 1, 5, it will generate a sequence of 5 numbers starting at 0 and ending at 1. Since endpoint is true, 1 is included in the sequence. And if we give the command with endpoint equal to false, the stop value is excluded from the generated sequence. So when we give the endpoint true, the last value is 1, and when we give the endpoint as false, the last element will be 0.8 in the sequence. Next is creating simple array using the return step parameter. The ret step parameter in the linspace function is an optional argument. That is, if it is set to true, it will cause the function to return a tuple instead of just an array. This tuple contains 2 elements. First element is a NumPy array of evenly spaced values, and second element is a float that represents the difference between each pair of consecutive values. For example, if we define an array with linspace as 0, 1, 5 and return step as false, it will give the output as the generated array. And if we print array and the step size, it will give the output as first it will print the array with evenly spaced values and the step size is 0.25. And if we define array with linspace as return step equal to true, and if we print array and step size, first it will print the tuple, that is array, with step size, and again it will print the step size as 0.25. That is, if we give the return step as false, it will return only array value, and if we give the return step as true, it will generate an tuple with array and the step size. Next is creating simple array using dtype parameter. For example, if we define an array with linspace as 0, 1, 5 with dtype as float, it will generate an array with float data type. And if we give the linspace with dtype as integer, it will generate an integer array. Since the data type is integer, it will generate first 4 element as 0 and last element as 1. Next we'll see the axis parameter of linspace method. The axis parameter basically allows the user to provide an axis for a generated sequence to be stored along. The axis parameter can be applied only when the start and end point of the data are of an array type. For example, here two NumPy arrays are defined with first array element as 1, 2, 3 and 4, 5, 6 and second array element as 1, 3, 9 and 5, 7, 11. And if we give linspace function with axis 0 and linspace function with axis 1, it will give the output as first it will print linspace function with element as 1, 2, 3, 4, 5, 6 and second as 1, 3, 9 and 5, 7, 1, 1. And if we give the axis as 1, it will combine 1, 2, 3 and 1, 3, 9 and 4, 5, 6 and 5, 7, 1, 1. Now we'll execute this linspace function in Jupyter Notebook. First we'll import the NumPy and we'll define array as np.linspace with parameter 0, 1, 5 and we'll print the array. And when we execute, it will generate evenly spaced 5 elements for the array, that is 0, 0.25, 0.5, 0.75 and 1. Then we'll see linspace function with endpoint. So array equal to np.linspace with parameter 0, 1, 5 and we'll print array and we'll define another array with linspace function with parameters 0, 1, 5, endpoint equal to false and we'll print this array. And when we execute this, by default endpoint is true. So when we use linspace with endpoint true, it will generate an array with last element as 1. And when we use endpoint as false, the last element will be 0.8, not 1. Next we'll see return step function. So array equal to np.linspace with parameter 0, 1, 5 and return step equal to true. Then we'll print this array and we'll define another array with np.linspace with parameter 0, 1, 5 and return step as false and we'll print array. And when we execute, when return step is given true, it will return tuple, that is first element is array and second element is step size, and when return step is false, it will generate only an array. Next we'll see linspace function with d type. So array equal to np.linspace with parameter 0, 1, 5, d type equal to float and we'll print array and we'll define another array np.linspace with parameters 0, 1, 5 and d type equal to int and we'll print the second array. And when we execute this with data type as float, it will generate an array with element of data type float, and when we give d type as int, it will generate an array with integer value. And next we'll see linspace with axis parameter. For this, first we'll define two array. So array equal to np.array with parameters 1, 2, 3 and another elements with 4, 5, 6 and we'll define another array with 7, 8, 9, 10, 11, 12 and we'll use linspace function. So op1 equal to np.linspace with array and array 1, 2, axis equal to 0 and we'll print this. And we'll use another linspace function. So np.linspace with array, array 1, 2, axis equal to 1 and we'll print second array, that is op2. And when we execute this, to check this, first we'll print array and array 1 and when we execute, first it will print array with first array as 1, 2, 3, 4, 5, 6 and second array as 7, 8, 9 and 10, 11, 12 and when we use linspace function with axis 0, it will print default array as 1, 2, 3, 4, 5, 6 and 7, 8, 9 and 10, 11, 12 and when we give the axis 1, first it will give first row from the first array, that is 1, 2, 3, and first row from the second array, that is 7, 8, 9, and then 4, 5, 6 and 10, 11, 12.